Greetings, science family. Today we're going to be looking at our quiz review for the kinetic and potential energy quiz. I'm going to drop down to number 4 to go through some of the math problems with kinetic and potential energy. Number 4 starts off, it says Nita is roller skating and moving at 3.5 meters per second. So if she's moving at 3.5 meters per second, that's going to be my velocity. So here we go, 3.5 meters per second. She also has a mass of 72.5 kilograms. 72.5 kilograms is my mass, and we want to know her kinetic energy. So the question is, what is her kinetic energy? Now we know from the top of our paper that the equation for kinetic energy is 1/2 times mass times velocity squared. So if we start plugging in for that, we don't know kinetic energy, we're going to want to solve for it. But we know 1/2, we know the mass, right? The mass is just 72.5 kilograms. And we also know the velocity. The velocity is 3.5 meters per second. And I'm going to square that. Now that I do that, I'm going to start figuring out my answer. I'm going to take 1/2 times 72.5. That's going to give me about 36.25. And I'm also going to take 3.5 squared. So that's 3.5 times 3.5. That gives me 12.25. Now that I have that, I'm going to take those two numbers and multiply them together. When I do, kinetic energy is going to equal to 444. So 444.06. But remember, since it's energy, we have to give it a unit, and that unit is joules. So overall, the kinetic energy ends up being 444.06 joules. Jumping to number 5, it says, if Rafiki holds up baby Simba 1.5 meters into the air, that means that it's at a height of 1.5 meters up into the air. So that's a height. What would Simba's potential energy be? And I better shrink this down here so that we can read this whole problem. What would Simba's potential energy if his mass is 3.68 kilograms? So we know 3.68 kilograms is going to be baby Simba's mass. And we're looking for potential energy, PE. Well, we know that potential energy is just mass times gravity's acceleration times height. So we can start plugging into that to solve for potential energy. We'll leave potential energy as PE since we don't have it, but our mass is next, and our mass is 3.68 kilograms. Our gravity is next. We know that gravity's acceleration is always 9.8. And then our height right here is 1.5. So if I put that all together, multiply that out in my calculator, I end up getting 54.1 joules of energy. So that's the total potential energy for baby Simba. Jumping to number 6, we want to know if you have a 0.43 kilogram soccer ball. So that's going to be my mass, 0.43 kilograms. It has we want to know what the ball's velocity is. So I guess the good question is, what is its velocity? That's my question mark. And we know that it has 48.4 joules of kinetic energy. So we're given that it's 48.4 joules of kinetic energy. All right, let's make some room to do this problem. So I know right off the bat that kinetic energy's equation is 1/2 mass times velocity squared. Now, I know that I have some of these pieces already. I have kinetic energy, so I'm going to plug that in. 48.4 joules. 1/2 is part of the equation. Next is my mass. My mass is 0.43 kilograms. And last is my velocity, which is what I'm solving for. So I'm going to leave this as v squared. Now that I have that, I'm going to start doing some of my math to help me out. I'm going to leave 48.4 alone for right now, nothing to do with that. But I am going to multiply the 1/2 and 0.43 together. And when I do that, I end up getting about 0.215. So now that we're consolidating a little bit, I've got that, but I want to get v squared by itself. So I'm going to divide both sides by 0.215. Why? That's so that I can cancel out 0.215 and have velocity squared all alone. When I take 48.4 and divide it by 0.215, I end up getting about 225.12. Now be careful, a lot of people make the mistake and think, oh good, I'm done. That's what V equals, but that's not true. There's still this square there. So we have to square root both sides. When you square root V squared, you end up with velocity by itself, which is good. And you get about 15.00 after rounded meters per second for your answer after you square root 225. Now remember, your units are meters per second because that's velocity. You have to have that and make sure you put in your units. But we solve for that. And I think the square root part is what's been getting some people. So make sure you pay attention and you know how to do that in your calculator. Checking out number 7, it says a mass of 6 kilograms. So right away we're given a mass is 6 kilograms, is raised a vertical distance of 150 meters. So to me, if it's 150 meters up in the air, that's its height. We want to know what that mass's potential energy is. So the question is, what is its PE? Now we know that potential energy's equation is mass times gravity times height. Potential energy is something we don't know, but we can start figuring out the rest. My mass, as I know, is 6 kilograms. My gravity, we know, is always 9.8 on planet Earth. That's the acceleration of gravity. And then my height is right here, 150 meters. So when I really do this, I'm just putting this all together and I'm going to multiply. And when I do multiply 6 times 9.8 times 150, I end up getting 8,820 joules for my final answer. And there you go. We've completed number 7. Again, don't forget, anything with energy ends up in joules for an answer. Looking at this problem right here, you have a big roller coaster. And as it says, you have a person in the car. The total mass is 155 kilograms. From all this information, you want to try to figure out the different pieces of information below. So if we look at part A, we're at the very top of the roller coaster, and it looks like there's no initial starting velocity, which means you're not moving yet. You're right at the top. So that means if there's no initial velocity and we're not moving, there's going to be no kinetic energy. So that's an assumption that we can make. However, since we have all of that mass and we're at a height of 92 meters above the ground, there's definitely potential energy here. So let's solve for that potential energy. We know that potential energy is mass times gravity times height. So if we're going to solve for that potential energy, we know that the mass of the object, according to our problem, is 155 kilograms. We know gravity is 9.8 always. And we know that the height of this roller coaster is 92. So when we multiply those three numbers together, we end up getting around 139,748 joules for my potential energy. So that's what I'm going to put right here. 139,748 joules will be my energy. Now, because of that, remember that kinetic and potential energy added up is the total energy. So really, what this first value equals is not only the potential energy, but also the total energy in the system. And as we go down the roller coaster, we know since it'll get lower, potential energy will drop, kinetic energy will increase. As you go higher, the potential energy will increase and kinetic energy will decrease. So there's going to be a transfer of energy between potential and kinetic throughout. So let's keep that in mind when we start calculating everything else. If we look at part B and look for the potential energy, It looks like this cart is going to be about 56 meters high. Well, again, we know that potential energy is going to be the mass times gravity times height. So we already know that the mass hasn't changed, it's 155. We also know that gravity hasn't changed, the acceleration is 9.8. But now the height is 56 meters. So we're going to plug that in. When you multiply that all together, you end up getting about 85,064 joules. So let's put that in, 85,064 joules for the total potential energy. Now, the question is, how will we find kinetic energy? Because if you plug into the kinetic energy equation, we don't have velocity yet. So I don't know how to solve for this. But luckily, we know that the total energy of the system is always equal to the potential energy and the kinetic energy added up. So if we know the total energy was that starting potential from part A, that total energy was 139,748. We also know that the potential energy right now in part B is 85,064. We know that that number plus whatever the kinetic energy is for this part B, that's going to have to be added to this potential energy to give you the total. So what we'll do is we'll just subtract 85,064 from both sides. All right, if you do that, kinetic energy ends up equaling 139,748 minus 85,064. And what you end up getting is about 54,684 joules. So let's write that in there. 54,684 joules gives us. Now remember, when we add up these two together, they should always equal the total energy. Now that we have kinetic energy, we can solve for the velocity. Why? Because we know that the kinetic energy equation is 1/2 times the mass of the object times its velocity squared. So if we do that, we just solve for the kinetic energy, so we can plug that in, 54,684. We know that there is 1/2 times the mass. We know the mass has been 155 the whole time. And we'll have v squared. So let's start solving this out a little bit. We know we have 54,684 on this side, but now we need to multiply 155 times 1/2. When we did that, 155 times 1/2, we end up getting about 77.5, and we still have our velocity squared. As you guys know from your algebra, we need to get velocity squared by itself. So we're going to divide both sides by 77.5. When you do that, that cancels out and you're left with velocity squared. So what we're going to do is take the 54,684 divided by 77.5. And what you end up getting is about 705.6 for your answer there. Now that we have that, we need to get velocity squared turned into velocity. So to get rid of that squared, we're going to square root both sides. Velocity ends up equaling 705, take this 0.6, take the square root of it, and you get about 26.56 for an answer. Now the question is, if this is velocity, what are the units going to be? They're not going to be joules because joules is energy. Remember, velocity is how fast you're going, so that's meters per second. All right, now we got part B done. We can go to part C next. Rocking out potential energy of part C, we know it's 75 meters high. As we know, potential energy is mass times gravity times height. So to solve for potential energy, let's plug in the mass, 155. Gravity is 9.8, and the height is 75. Multiply all three of those across, 155 times 9.8 times 75, and you end up getting about 113,925. So let's put that in there, 113,925 925. And since it's energy, we're going to put that in joules. Now to get kinetic energy, we're going to do it the same way we did the part B. We know that the total energy is equal to whatever the potential and kinetic energy are added up. As you remember, the starting potential energy really is your total energy of the system. So there's 139,748. When you take the potential energy that we have right now, 113,925, that plus whatever the kinetic energy has to equal the total energy. So we'll just subtract 113,925 from both sides. And when we end up doing that, 139,748 minus 113,925, you end up getting about 25,823 joules. Now, I just want a quick note here that these two added up are the same as these two added up, which are the same as these two added up. That's because of the conservation of energy. The idea that you started with a certain amount of total energy and it just transfers back and forth between kinetic and potential energy. All right, so just keep that in mind. That's why this worked out the way it did. But let's figure out that final velocity and finish up this problem. To find the velocity, we know that we are going to have to dig deep and look into the kinetic energy equation. But we have velocity in that equation, so we should be good. That means we just have to plug in now. Our kinetic energy, which is right here, is 25,823. We know we're going to put 1/2 times the mass. The mass of everything has been 155 this whole time. And we're going to do the velocity squared. Now we're going to combine some like terms. So we're going to do 1/2 times 155. And when we do that 1/2 times 155, we end up with 77.5 times velocity squared. And don't forget over here, we have the 25,823. Now we are going to divide both sides by 77.5. That's going to get velocity squared by itself. When we take the 25,823 and divide it by 775, we end up getting about 333.2. Now be careful because that isn't your final answer, right? We need to square root that to get V by itself. And when we do that and get V by itself, we get about 18.25 for our answer. Question is, what are the units for velocity? 18.25 what? Meters per second. Excellent. If we take a look too, does this make sense that as I erase here to show you guys a little bit, does it make sense that the cart isn't moving as fast when the hill is at a higher point? So when the cart is right here, the cart is moving about 26 meters per second. When the cart is even higher up on the hill, it's moving slower at 18 meters per second. Make sure that makes sense to you in your brain, and it should, because the higher up you go, the slower it got as it went up that hill, right? As a roller coaster goes up the hill, it slows down. It transfers that energy to potential as it goes higher. So it makes sense that down here, it's moving faster than here. The fastest point this roller coaster car would be moving is probably right here towards the bottom of this first big hill, all right? Or down here towards the bottom, even closer to the ground. So the lower the cart is, the faster it's moving. The higher it is, the slower it's moving. Again, because you're transferring between potential and kinetic energy. All right, Science Fam, I think that's enough for review, but hopefully some of these problems gave you some confidence and help and guidance that you needed to get through them. Take care and don't forget to ask questions in class. Be well.